All right, so if A, B, and C are all midpoints, that means that each mid-segment is parallel to the third side. So AC is parallel to EF. AB is parallel to DF. And BC is parallel to ED. Okay, so A, B, and C again are all midpoints. So name all angles that are congruent to angle D. Well, I know that angle EAB is congruent to it because AB is parallel to DF, so these are corresponding angles. And then I know that all four smaller triangles are congruent. So I need to determine how to rotate and reflect this triangle to fit onto the other ones. Okay, so using the markings, I know AB is half of DF, so AB is congruent to DC, which has 3 markings. So BC is half of ED, which means BC is congruent to EA, which has 1 marking. And then AC is half of EF, so half of EF is just EB, which is 2 markings. Okay, so angle D is the angle included between the 1 marking and 3 marking sides. Okay, so I already did that over here. So also this angle between the 1 and the 3, and this angle. Okay, so in addition to EAB, there's also angle ABC and angle BCF. Okay, given perimeter of 60 and MP and N are all midpoints, so let me label the midpoints. What is the perimeter of XYZ, the big one? Okay, well, MNP is perimeter of 60, so we take away 24, that leaves 36, take away the next 22, that leaves 14 for the last side, NP. And then I know that mid-segments are half the length of the third side, so if this is 14, then XY is double that. And then if this is 24, then XZ is double that. And YZ is double 22, so 44. So adding the perimeter together, let's see, 16, 0 gives 2, 4, 12. So 120 centimeters. Okay, find the measure of VUZ and angle Z. Okay, so these are U and V are mid-segments. I can tell from the side length markings. So that means that UV is parallel to XY, which means that I can use corresponding sides to see that angle VUZ. Measure of angle VUZ is also 65 degrees because corresponding angles are congruent. And then I can use the fact that this big triangle adds up to 180 degrees. Okay, so I take away the right angle, that leaves 90 degrees. Take away the 65 degrees, that leaves 25 degrees for the last angle, which is angle Z. Given A and B are midpoints, so that means these are congruent and these are also congruent. So first, let's set these two congruent segments equal to each other. Okay, so y is 6. And I can also set these two sides equal to each other. And finally, I know that the mid-segment is half of the third side. So I would have to double the mid-segment to equal the third side. Okay, so I'm going to double the mid-segment. So instead of 2x, I'm going to double it. And now that should equal the third side. Okay, so 4x equals x plus 6. Alright, so x is 2, y is 6, and z is 3. Okay, given AB is 10 and CD is 18, find the measure of a lot of other stuff. Okay, well these two segments are marked as congruent, so BC is also 10. And then I know that this is a mid-segment from the markings, so I know that this is 18, so this is half of 18, so half of 18 is 9. And then, so BC is 10, AC is 10 plus 10, and EB is half of 18, which is 9. Okay, so solve for x and note that it is not given as a mid-segment. Okay, so this is kind of tricky because on this side we have the full big leg compared to this little section, which is only part of it, while here this is split into two different sections. So we want to compare the same sides with each other. So if the full distance across the top is 28 and this section is 8 of it, that leaves 20 for here. Okay, so now I can compare this side to this side and this little section to this little section. So remember, there are many possible proportions that would lead to the same answer. Okay, so I'm going to cross multiply. So remember here I need to distribute. 8 times 3x is 24x, 8 times negative 5 is negative 40. And now I just solve for x. Okay, so 240 divided by 24 means that x is 10. Alright, solve for x and y, given that AC is parallel to A prime C prime, but A prime and C prime are not given as midpoints. They might be, but we're not sure. Okay, well, we can actually know that they're not midpoints because this if it were a mid-segment, it would have to be half of this, which it isn't. Okay, so we're gonna have to set up a proportion. So there's different ways we can do this. So we know that these two triangles are similar. They share side B, or sorry, angle B. And then if these two are parallel, then these are corresponding angles. So these are similar by a similarity. Okay, so now that we know that the sides are similar, we can set up a ratio. Okay, so let's do y first. Okay, so 14 to 22. Okay, so we got to be careful here because 14 is the entire bottom side of the small triangle, 22 is the entire bottom side of the big triangle. Okay, so y is the entire right side of the small triangle, but 15 is not the entire right side of the big triangle. The right side of the big triangle is y plus 15. Okay, so we're going to have to solve this. I'm going to start by reducing this fraction just to make the number smaller. And now I will cross multiply. So remember to distribute. 7 times y is 7y, 7 times 15 is 105. And then on the other diagonal we have y times 11. Okay, so 105 equals 4y. And then y equals 105 divided by 4, which is 26.25. Alright, so now to get x. So I'll do this one differently. So now that I know y, I can set up a different proportion. Okay, so this section, so the entire right side compared to the leftover right side. So y is 26.25 over here compared to the leftover should equal the left side compared to this leftover. Okay, so cross multiply. 15 times 30 is 450. 26.25 times x is 26.25x. Okay, and now we divide both sides by 26.25. Okay, so we get some repeating decimal, so we may prefer it in fraction form instead. Which one? This one doesn't do. Okay, well, it turns out to be 17 and 1/7 is the exact answer. Okay, so finally, all right, so you're a person. You walk a certain distance from a building. So here's the building you walked away from. Okay, so you walked away, you put a mirror on the ground, and then you kept walking away until you see the top of the building in the mirror. Okay, so this picture is not really accurate because the angles should be the same. So let me retry that. Okay, so here's the building. You start here, you drop a mirror on the ground, and then you walk a little further away. Okay, so now you can, here's your line of sight. It bounces off the mirror, and it sees the top of the building. Okay, so why is this helpful? Because now you have two right triangles, and we know that the mirror bounces your sight off at the same angle. So that means that we have two similar triangles by a similarity. Okay, so you are standing in the shade of a tree. Okay, so here's the tree. Here's the sun. Okay, so the shade is like this. And then you're standing in the perfect spot where your shadow and the tree's shadow are in the same place. Okay, so here's the tree's shadow. And then let's say that here's your shadow. Okay, so they end in the exact same place. Well, again, we have similar triangles, right? So here's one triangle. So we know this is a right angle because you're standing straight up. And then you have another triangle over here. So again, the tree is going straight up, so that's a right angle. And then both triangles have this same angle right here. So again, we can use AA similarity.